Hello everyone. So here in this problem we have to solve the given equations by Cramer's rule. It means we have to find out the value of x, y and z which is given in the equations. Now to get the value of x, y and z by Cramer's rule, we want the equations in the linear form of x, y and z. But if you see here, then we have two variables together. So first of all, what we will do is, if you will observe the right hand side, then here we have 2xyz, then xyz and 3xyz. It means in the right hand side we have this xyz term extra, but if we want the equation in the linear form, then we want constant on the right hand side, and to bring the constant on the right hand side we have to remove this xyz from all the three equations, and for that reason we will divide the three equations by x, y, z, so that the x, y, z from the right hand side will be removed. So here I will say dividing each equation throughout by x, y and z. So by dividing yz with xyz, yz and yz will be cancelled and we will get 1 upon x. Here we will get 2 upon y because xz and xz will be cancelled. Here we will get plus 1 upon z because xy and xy will be cancelled, and in the right hand side we will get 2 because this xyz and xyz will be cancelled. So I will say this as first equation. Now let us divide this second given equation by this xyz. So here we will get 3yz upon xyz, that is 3 by x, minus 4xz upon xyz, that is minus 4 upon y, and minus 2xy upon xyz, that is minus 2 by z, equal to xyz upon xyz is 1. I will say it as equation number 2. Next, 2yz upon xyz, that is 2 upon x, 5xz upon xyz, so plus 5 upon y, and minus 2xy upon xyz, that is minus 2 upon z. So 3xyz upon xyz will give us 3, and here we will get equation number 3. So we got three equations, but still if you will observe, they are not in the linear form. So if we want to reduce them in the linear form, then here we will assume this 1 upon x as a, 1 upon y as b, and 1 upon z as c. So therefore here I will say to reduce equation number 1, 2 and 3 in linear form, take 1 upon x as a, 1 upon y as b, and 1 upon z as c. So by this we will get here a plus 2b plus c equal to 2. So it will become therefore a plus 2b plus c equal to 2. Next, the second equation will become 3a minus 4b and minus 2c equal to 1. So 3a minus 4b minus 2c is equal to 1, and here third equation will be 2a plus 5b minus 2c equal to 3. So 2a plus 5b minus 2c is equal to 3. So now we got the three equations in linear form. So now let's find out the value of D, then DA, DB and DC by using the Saru's rule, and after that we'll apply the Cramer's rule to get the value of ABC, from which we can find out the value of X, Y and Z. So therefore I'll say by Saru's rule we'll get determinant D as, now D is nothing but the determinant of coefficients of variable. So here the variables are A, B, C. So the coefficients of A are 1, 3, 2, then 2, minus 4, 5, and the coefficients C are 1, minus 2 and minus 2. So by solving this we'll get 1 into minus 4, 5, minus 2, minus 2, minus 2 into 3, 2, minus 2, minus 2, plus 1 into 3, 2, minus 4, 5. So we'll get 1 into, this is 8 and this is minus minus plus 10. This is minus 2 into minus 6 plus 4 plus 1 into 15 plus 8. So this will become 18 into 1, that is 18, minus 2 into minus 2, that is plus 4, and 15 plus 8, that is 23. So if we'll add this, then we'll get 18 plus 4, that is 22, plus 23, that is 45. So we got the value of D as 45. Now next we'll find out the value of DA. So to get value of DA by Saru's rule, we'll replace the coefficients of A by the constants. So here these coefficients of A, that is first column, will be replaced by constant. So that will become 2, 1, 3. Second and third column will remain as it is, which are nothing but coefficients of B and C. So 1, minus 2 and minus 2. So if we'll solve this, then here we'll get 2 into minus 4, 5, minus 2, minus 2, minus 2 times 1, 3, minus 2, minus 2, plus 1 into 1, 3, minus 4 and 5. So we will get, this will become 8 plus 10 minus 2 into minus 2 plus 6. This will become 1 into 5 plus 12. So here we will get 18 into 2, that is 36. This will be 4 into minus 2, that is minus 8, and 17 into 1, that is plus 17. So we will get 36 minus 8, that is 28, and 28 plus 17 will become 45. So the value of DA is also 45. Now let's find out the value of DB. So to get the value of DB, we'll replace the coefficients of B by the constant. So here the middle column will be replaced by the constants. So this will become DB equal to 132 as it is. Middle column will become 213, that is coefficient, that is the constants, and the last column is as it is, that is 1 minus 2 minus 2. So by solving this determinant, we will get 1 into 1, 3, minus 2 minus 2, minus 2 into 3, 2, minus 2 minus 2, and plus 1 into 3, 2, 1, 3. So we'll get here minus 2 plus 6, minus 2 into minus 6 plus 4, plus 1 into 9 minus 2. So we'll get 4 into 1, that is 4. This will be minus 2 minus 2 that is plus 4 and 9 minus 2 that is 7. So 7 into 1 is 7. So this will give us 15. 8 plus 7 that is 15. So we got the value of dB as 15. Now let's find out the value of dC. So to get the value of dC by Saru's rule, we replace the coefficient of C by the constant. So the third column will change and it will be replaced by 2, 1, 3. First and second column will remain as it is. So therefore dC is equal to 132 as it is, 2 minus 4, 5 as it is, and the last column will be replaced by the constant. So 2, 1, 3. Now by solving this, here we will get 1 into minus 4, 5, 1, 3 minus 2 into 3, 2, 1, 3 and plus 2 into 3, 2, minus 4, 5. So here we will get minus 4 into 3 that is minus 12, minus 5, minus 2 into 9 minus 2 plus 2 into 15 plus 8. So this is minus 17 into 1 that is minus 17, 9 minus 2 7, 7 into minus 2 that is minus 14, 15 plus 8 that is 23 and 23 2s are 46, so plus 46. So if we will calculate this, then here we will get minus 17 and minus 14 that is minus 31 and minus 31 plus 46 is 15. So the value of DC is also 15. So we got value of dB and DC as 15 and the value of D and DA as 45. Now let's find out the value of ABC by using Cramer's rule. So I'll say therefore by Cramer's rule A is equal to dA upon D. So the value of dA is 45 and the value of D is also 45. So the A is equal to 1. Next, B is equal to dB upon D. Now the value of dB is 15. So 15 upon D, D is 45. So the answer is 1 by 3. And similarly, the value of C is DC upon D, where DC is 15 upon 45, that is again 1 by 3. So the value of A is 1, B is 1 by 3 and C is 1 by 3. But if you will see the question, then here we have the question in terms of x, y, z. Hence we have to find out the value of x, y and z. So now we will make use of these relations. So we assume that 1 upon x is A, 1 upon y is B and 1 upon z is C. So I will substitute the value of A, B, C over here. So I will say, but A is equal to 1 upon x, B is equal to 1 upon y and C is equal to 1 upon z. Now therefore the value of A we got 1 is equal to 1 upon x, the value of B we got 1 by 3 which is 1 upon y and the value of C we got 1 by 3 that is 1 by z. So here by taking inverse we will get x equal to 1, here we will get y equal to 3 and here we will get z is equal to 3. So the value of x is 1 whereas the value of y and z is 3. Thank you.